Plots are useful, but it's also useful to have quantitative results. Remember, a statistic is a single number that summarizes a numerical data set. We can use the method describe to list summary statistics of the numerical columns of the IRIS data frame. The output of describe includes counts, means, standard deviations, minima, first quartiles, medians, third quartiles, and maxima from all the numerical columns of the data frame. Let's learn what these statistics mean in detail. The count method returns the number of non-null entries in a given numerical column. The series method count returns a scalar integer. The data frame method count returns a series of counts computed over each column. The mean method computes an average of a series and the average of data frames column-wise, ignoring null entries. All series and data frame statistical methods ignore null entries. This is particularly important to ensure summary statistics like averages are not diluted by null entries. The SDD method computes the standard deviation of the non-null entries of a series. Remember, if the mean measures the tendency to a central value of a measurement, the standard deviation measures its spread. For instance, with a bell curve distribution, the mean is roughly at the middle and the standard deviation is roughly the width of the bell curve. The mean is not the only measure of centrality used in statistics. The median method computes the median of a series. Here, the median sepal width 3.0 centimeters tells us 75 of the 150 observations have sepal width smaller than 3.0 centimeters, and the other 75 has sepal widths larger than 3.0 centimeters. Similar interpretations apply to the other columns. A median is a special example of a quantile. If Q is a number between 0 and 1, the Qth quantile of a data set is a numerical value that splits the data into two sets, one with the fraction Q of smaller observations and the other with larger observations. Colloquially, quantiles are called percentiles, using percentages between 0 and 100 rather than fractions between 0 and 1. The median, then, is the 0.5 quantile or 50th percentile of a dataset, as verified using methods median and quantile Q with Q equals 0.5. The quantile method computes the median by default. Given a fraction Q, it returns the Qth quantile. The quantile method also accepts a list or array of values between 0 and 1. So for instance, using Q equals 0.25, 0.75 as a list, with quantile Q returns the interquartile range, or IQR, between the 1/4 and 3/4 quantiles. Again, we see the IQR for the petal length is between 1.6 centimeters and 5.1 centimeters, telling us half the data collected lies in this range. The range is the interval between the smallest and largest observations. These are given by the min and max methods respectively. Notice these two methods also return values for the species column, notably the first and last strings in the columns when sorted in alphabetical order. Remember, we can use the plot method with kind equals box to draw box plots. The plot shows the range and interquartile ranges graphically. You can read off the minimum, the 1/4 quartile, the median, the 3/4 quartile, and the maximum for all columns of the data frame. The box plot uses exactly the same data as reported by describe. Notice the quartiles are reported as percentiles by describe. Now that you understand what these statistics are, you can do some statistical EDA on your own in the exercises.